Good evening, everyone, and a very warm welcome from Umbrella and AWS to everyone here. I'm Aparna, Head of Marketing at Umbrella Infocare, and I and my team are very happy that you were able to join us today. Today, we have a group of great industry leaders across financial services and technology services. And we are going to be talking about big data analytics. And we are all very aware of the growing relevance of data and analytics in various business areas. We know about the high value of analytics for customer insights, improving marketing ROI, improving operational efficiencies, and getting real-time insights for business success, as well as leveraging data for a large number across your business. So today we are going to get a few insights into these areas from our big data analytics experts. And without further ado, let me introduce you to the speakers of the evening. Meghanathan is a solutions architect at AWS, designing scalable, resilient, high-performing, secure, and cost-effective architectures. Startups align technology with their business goals for growth and success. He's also skilled in technical architecture, solution design, development and delivery, and has worked in multiple modernization and migration projects over the years with various cloud service providers. Welcome, Meghanathan. Satish, who heads the data and analytics team at Umbrella, has around 15 years of experience in deploying technical solutions across the globe. He's passionate about anything and everything data and has a deep-seated love for data analysis. He has experience across domains, including telecom, finance, gaming, healthcare, to name a few. Satish is truly a proponent and strong advocate of cloud and related technologies and considers that to be the future within the industry. Help from you to understand your interest in the topic today. I'm going to pull up a poll. Please give me a minute. I would like you to answer this poll. It's a very quick poll and we have only 2 short questions. Thank you for your cooperation. Give me a second, please. Sorry, this is not functioning well. So I'm going to run this poll later on for you. I'm going to hand this meeting over to Meghanathan now. Please give me a second. Meghanathan, you can get started, please.
Thanks, Aparna. Can you confirm whether you're able to see my screen?
Yes, we can.
Okay. Okay, hi everyone. This is Meghanathan. I am the solutions architect at AWS. Like today, I'm going to talk about we think about terabytes is a huge volume of data. Now, right, the data has been exploding like terabytes to petabytes and even exabytes of data. Like handling this much data, right, on premises on a big data strategy will not be feasible, and also, right, scaling will be a challenge and it will be expensive as well, right? To help that, right, AWS comes up with various data analytics services. We'll see that in detail one by one. The first thing is like we talk about the data volume. The second is like data is coming now from different sources, right? Earlier we have where we get the data. Now, right, we are getting data from different sources, right? Say, for example, it can be from web application logs. It can be from, say, clickstream data. It can be from, say, unstructured in nature. And similarly, for example, if you talk about data that is pulled from an API, right, which is actually can be in a JSON format, which is semi-structured, right? So to handle all three types of data, right, it can be structured, unstructured, and semi-structured data. So we need a mechanism, right, to process that so that we can derive insight out of it. The fourth thing is, right, this data will be used by different people, right? It can be from within the organization, it can be from data scientist team or data analyst team or even data engineering team, right? And each need different access patterns on your data, right? And finally, right, we access these, right, using different analytics application, right? There is no one standard application that help you to solve all the use cases, but we need different applications to solve different use cases, right? We'll see that in detail. So the first thing is, right, how to put the data, like we discussed about, we have huge amount of data that is coming from different sources. How I can put the data to work, right, to make a better informed decision, how to improve my processes, and how can I respond faster to the unexpected, and also how to uncover new opportunities, right? So this, to do that, right, traditionally we follows, I'll talk about the traditional data approach versus modern data approach, right? As on the left hand side, whatever you see is the traditional data approach, right? Where actually what we usually do is, right, we have multiple transactional databases, which we'll push that data to a data warehouse, and then we'll run some business intelligence tool, right, on top of it to generate some insights out of it. Similarly, right, if the data is non-relational in nature, like for example, data that is coming from sensors or IoT devices or web applications, right, we push that into a different data warehouse and then like again apply business intelligence on top of it, right? If you see, right, the data are not it's in silos basically, right? It's not in a central repository, and also, right, to derive a proper like we don't get a single source of truth, right? Since the data is available, the same data can be available in two different sources now, right? So that's why, right, people are now moving towards a modern data approach, right? When I say modern data approach, right, you heard about the term data lake, right? So data lake is one of the modern approach, and we do have data lake house approach, right? So I'm going to discuss in detail both the approaches. The first one is data lake approach, right? When I say data lake, right, we'll have a data lake is basically a centralized repository where you keep all your structured data as well as unstructured data into a single place, right? You're not keeping that into two different like warehouse as we saw in the earlier case, traditional case. But here we are keeping all the data, whether it can be relational data or non-relational data, we are keeping into a data lake. So once the data is available in a data lake, right, and you can see, right, we have many different data services, right? For example, it can be relational database, it can be a data warehouse, right? It can be a tool that helps to analyze the logs, right? It can be big data processing services, or it can be machine learning. So all these services are linked directly to your data lake. So from the data lake, right, you can say basically you can move the data inside out or inside in, basically bring the data from a data warehouse to a data lake. So both the options are bidirectional. Basically all the connectors, whatever you see, right, it's all bidirectional. And also the services are interlinked across these plane as well. For example, from the big data processing, right, I can do log processing as well. For example, I can connect a log analytics services and do big data processing on top of the data as well. So all are interconnected, right? This approach we call it as a lakehouse approach, because we have the data centralized repository and I can do like whatever data analytics related operation on top of my data using different data analytics services. So to set up that, right, how do I need, so for example, we discussed about data analytics and data lake basically, right? So how do I set up the data lake, right? We discussed about different on-premise data sources, right? We discussed about on-premise data like from an application servers, or it can be streaming data from different third-party social media websites, or it can be from your relational database or database that is running on the cloud as well, right? It can be an RDS as well. So we need to find out a way to bring this data to a data lake first. And for that, right, we have different options needed, right? First, we need a connector. So basically, connector is an ingestion pipeline. How can I bring my data to my data lake, right? Once I have the data, right? So traditionally, right, if you see a data warehouse, right, before we load our data into a data warehouse, right, we create the schema, right? Basically, we call it as a schema on write, right? Without a schema, right, you cannot load a data into a data warehouse or any databases, for example, right? So first we need to define a table and then we need to load the data into the table, right? The same way, right, with respect to data lake, right, we are keeping all the data in an open format, right? We discussed about unstructured data or semi-structured data. Also, we are keeping it in S3, but we need a way, right, to read the data, right? For that, we need a catalog, right? Basically, catalog is like we need to crawl the data that is available in your data lake and define a schema out of it and store it into a catalog, right? The third thing is we need to do a transformation. So once we have the raw data available in S3, whatever we pulled from different sources, I need to transform the data depending upon my business use case, right? For example, the data type can be different, right? I want to compress the data, or I can want to convert that into columnar format, right? All this transformation you can need to do so that these data will be available for further processing using different data services, right? So to do that, right, we have within like data lake, right? Think data lake as your S3 bucket. We'll see why S3 is the best option for setting up a data lake in the next slide. And then, right, we have lake formation. So lake formation is a service, right, which actually provides you the connector that is needed to bring the data, and crawler that needs to crawl the data and create a catalog and transform the data. So everything, it has a tight integration to Glue. Basically, Glue provides all these features, right? For example, to crawl the data, Glue provides a Glue crawler. And then to store the catalog, right, we have a Glue data catalog. This is a unified catalog available in AWS where you keep all the schema information in a single place. The third one is transformation, right? For transformation, Glue provides Glue Studio, right? Where actually it's a visual way where you can directly create a transformation by just click and drag and drop different components and make your transformation ready for data processing, further processing, basically the cleansing the data, right? So as I discussed, right, so all these three layers are interconnected, and Athena is again a service which is actually help you to fire a SQL query on top of your data that is available in S3 using Glue data catalog. So catalog will provide the schema information, and Athena will fire the SQL queries top of the data that is available in S3. So we are not moving the data from S3 to Athena. It's actually schema on read. So the schema will be available here for the data that is available in S3, and Athena will read the data directly from S3. Okay. And apart from that, we discussed about many different data services, right? For example, think about Redshift, right? Redshift is a data warehouse service where actually, say, for example, from S3, right, you can keep all your hard data in Redshift, and all the data, historical data, you can push it to S3 because S3 is the cheapest storage. And again, if you want to do log and search analytics, you can have OpenSearch service, which is a managed Elasticsearch service. And for relational and non-relational database, we have connectors to Aurora DB as well as DynamoDB. And for big data processing, right, we have Elastic MapReduce service, which is EMR, that will help you to process a huge amount of big data. Like for example, you can run any of the Hadoop ecosystem tool on top of your data that is available in a data lake. And if you want to build machine learning on top of your data, we have SageMaker as well. So these are high level different services that are interconnected within your data lake, which will give a lake house effect. So we discussed about S3 as a data lake, right? Why S3 we choosing as a data lake, right? Because it has 11.9 durability and high availability. So a copy of data will be available in, so for example, if you keep a copy of your data, that will be distributed into 3 different availability zones. So it is highly available, and you can scale up to exabytes of data. So for example, if you think about a data warehouse, you can keep up to like say terabyte, right, or petabytes of data, right? But if you want to keep more like exabytes of data, and S3 provides an option, it can scale up to exabytes of data. And there are many ways, right, to you can ingest the data to S3 bucket. But there are like we discussed about, like for example, it supports API through SDK. You can push the data to S3 bucket, or from the console you can do that. And also it will support different SDKs for different programming languages as well, right? And query data in place, we discussed about Athena, right? So using Athena, you can directly fire a query against the data that is available in S3, as you do with the relational databases, right? The same way you can process the data, you can write views, and you can write functions on top of Athena. And finally, right, it actually have high security, right? So bucket level security, you can configure whatever security need you need, right? Which can be accessed, like privately access your bucket for all the users on your organization as well. And it also has audit capabilities. Like for example, you can enable cloud trial, so that like who modified your data on your bucket will be tracked directly from the cloud trial console, right? And S3 also provide different storage options, right? It has like standard storage, standard infrequent access, one zone infrequent access, and similarly like Glacier and Glacier Deep Archive for archival solutions. So depending upon your data access frequency and the data, like how you want to keep the data for the duration of the data you want to keep it, right? You can choose between different storage tiers as well. So this is the typical analytics portfolio AWS support. I have not included all the services. I just pick and choose the like major services. So any data pipeline, right? We have a data ingestion pipeline, and then we discuss about data lake, and then there is an analytics layer, and finally visualization layer, right? I'll talk about each layer one by one. For data movement, right? Data ingestion, right? If you have a relational DB and you want to migrate the data to a data lake, then you can use the database migration service. So which is DMS, right? This service will help you to migrate the data, whether it is a relational or non-relational database, directly to your S3 bucket, right? The second thing is, if you want to do it offline, right, there are multiple options available, right? You can use Snowball or Snowmobile. okay, using Snowball or Snowmobile, what you can do is like there will be an external device that will be shipped to your location, and then you can copy the data from the external device, and then you can ship it back to the AWS, and AWS will actually load the data into your data lake. And then for streaming sources, right, there are multiple options, right? You can use Kinesis Data Stream, Data Firehose, and Apache Kafka. So it's a managed offering provided by AWS. So using these services, right, you can bring the data to your data lake. So once you have the data in a data lake, right, so to speed up the process of creating the data lake, AWS comes up with a service called Lake Formation. This service will help you, right, to build, secure, and manage your data lake in days, right? So you can easily create that, right? Rather than you manually setting up your data lake, right? So basically, there are multiple activities, right? You need to collect the data, you need to catalog the data, you need to provide permission for the data. So everything, if you want to manually do that, that will be time consuming. If you use lake formation, right, it will make your like task much easier, right, to set up the data lake within few days, right? And it also uses Glue for all the activities which we discussed on the previous slides, right? Connect and catalog as well as the transform the data. Like lake formation has a tight integration to Glue. So once we have the data in a data lake, right, and then we need the data analytics services, whatever we discussed on the previous slide, the circle of services that surround your data lake, right? So it can be for data warehouse, we have Redshift. For big data processing, as we discussed, we have EMR. So you can run any one of the Hadoop ecosystem tool on top of EMR. And if you have only Spark and Python based transformation, right, then you can use Glue. And for Athena is for interactive query, you can query the data directly from your S3. And finally, for log and search analytics, you can use OpenSearch service. And for real-time analytics of your streaming data, you can use Kinesis Data Analytics. And for visualization, right, the last layer, right, you can use QuickSight. This is again a fully managed or a serverless service available where you can create charts or dashboards, right, directly on top of your data that is available in S3. So it has a good connectivity to your data lake as well as Athena. So by using that, you can create a number of visualization on top of your data. And for machine learning, we discussed about SageMaker. So you can build, train, and deploy models using SageMaker. You can bring your own model as well using SageMaker. I think you can have you can use your own algorithm like PyTorch and other services that will help you to build your own model on SageMaker as well. And there are other AWS AI services that will help you to various. We'll see that in detail in the next slide. So I'm going to touch base on some of the AI services that help you in the data analytics processing. Okay. So documents, right? These are the primary tool across any industries, right? We'll talk about financial industry first, right? So basically, right, how documents are processed today, right? There are manual process. For example, think about a loan application, right? If the customer want to apply for a loan, right, he'll feed in an application and give some necessary dependent document and then submit it to the lender, right? So all this, right, there will be a manual process. Like usually there will be a backend team who will feed in information into the application, basically, right? Which is actually error prone since it's a manual process. If they use like OCR, right, optical character recognition, and then again it supports simple documents only, and there are chances of error prone as well, like, and it will provide a dump of text, and you need to parse the data to keep that into the application layer. Basically, again, this is a challenge if you use OCR. Third one is rule and template based extraction. Again, we can define a template for different application, and then using that template, right, you can generate and extract the data. And again, this is like a lot of development and management overhead needed because you need to define different templates for different use cases as well, right? To help that, right, AWS comes up with a service called TechStract. So TechStract as a service, right, that it's actually an ML based model actually built in, pre-built for you, right? You don't need to know any ML experience to use this service, right? You can directly connect this API and start using this service from day one. And it alleviates all the manual efforts, right? Whatever the template developer, you don't need to build any template for this. And it is like accurately and quickly extract the data, and it just basically provide you with a key value per as well as the document. Like for example, if the document contain table, right, it will extract the table information as well directly for you, and then you can easily feed in that information into your backend application. And it is like cost is like compared to, like, it's much cheaper, right, compared to whatever OCR workload you run on premises right now. Okay. So the typical use case, right? For example, if you want to search an index document, right? So basically, right, whatever the application forms, whatever we collect from the users, right? You just upload all the forms into S3 bucket, which is your data lake right now. So from the data lake, right, automatically once a document has been uploaded, it will automatically triggers a Lambda function. So Lambda is a serverless function, right? Function as a service, basically. So it will, what it does is it will just call the TechStract API, and it will process the data, extract the information, and store it into a document store, or it can be stored into a S3 bucket. right? And then like you can also, for example, for index and searching the document, right, you can use open search service, which we discussed in the previous slide. This is a log and search analytics service. Using this service, right, you can easily index and enable document search. So it's very easy to do that. Everything is automated process, and you don't need to manually do any in the workflow, right? You don't need to manually intervene in any of the processes. The second case is like form capture. Say, for example, if you are getting the form from the application user, right, whether they are applying a credit card or whatever it is, right? So basically, we use think about that the user just capture the form, fill the form. Basically, just upload it using a mobile app. Through the mobile app, right, we can connect the extract API directly, and then it will extract the data and just populate the data form field directly into the application, right? Or whatever the backend application, right? They don't need to manually feed in any information. Just scan the information and automatically feed into the auto populate the form field directly into the application layer. And then like you can push that information back to your database by just a single click, right? So that you see it is using the extract APIs. The third use case is like recognition. This is again one of the key AI service. Like for example, think about that the same loan processing use case, right? So basically, when we apply a loan, right, usually we'll give a lot of application, we'll sign the document, and then we'll give some identity proof as well as the like address proof documents, right? So basically, there will be a backend team who will validate the data before load this information into the system, right? During the COVID period, right, there is no people started to innovate, right? How we can do that everything automated using online portal, right? So for that, right, they just use a recognition service. So what will happen is from the application, right, web application, right, you just fill the application directly through the web portal, and then you submit all the supporting documents, for example, identity proof as well as the like address proof. So what will happen, right, behind the scene, the recognition API will scan the image that is available in your identity proof and validate with the photo, whatever you uploaded, right? It validate whether it is a standard user, and then it will push it to the next stage on the loan processing services, right? Similarly, right, for example, eKYC, right? Again, backend, right, it uses it's a like fully managed services, right? We don't need to manually visit the bank to complete the KYC or submitting the document. There is no manual process. You can do it everything using eKYC, right? You can do that using the recognition service directly. Whatever we need to process, right, directly happen directly on the backend using the recognition APIs. We don't need any machine learning experiences as well. Okay. And there is one more service called Transcribe. Basically, this service will help you to, it's a speech recognition service. It's a fully managed AI service, right? And there is no machine learning experience required to use this service. Basically, what it does is it converts the speech into text, right? For example, I'll give a simple use case here. Say, for example, I have a pre-recorded media. I just want to convert that into a transcript file, right? So what I need to do is I just put that file into a S3 bucket, and immediately using a Lambda, right, you can call my transcript API, which actually will convert that into a transcription file. Similarly, you can use it for live streaming as well, right? I just feed in the live stream to transcribe APIs, and it will convert that into a text stream and then keep it into my document store for further processing. So these are some of the use cases, right, that will help you on your day-to-day processing, right? There are other services as well, for example, Lex for chatbot and other thing as well. So this is, it will help you on your analytics flow as well with respect to document processing. With that, right, I'll hand it over to Satish for further the rest of the presentation. If you have any questions, right, feel free to put it in the chat window. I'll answer that at the end. Thank you so much.
Thank you, Megha. Let me start my video and share my screen. Hope it is visible, the slide deck that I'm presenting.
Yes, Satish, I'm able to see.
All right. Welcome all. Welcome to the session on big data analytics. I believe Megha has done a very good job in explaining the AWS services and the applications. So in the second half of the meeting, for the next, I would say 10 or 12 slides, I'll be running you through with the actual use cases that we have developed in production for some of our customers. So we have handpicked 2 of the use cases. Now, the reason of picking these 2 use cases was to show you some tangible outcome of the analytics services which was deployed at the customer. In the first case, it was cost saving, and in the second case, obviously, a process improvement. Having said that, I will move on. The very first thing that I would like to do is to introduce ourselves. We at Umbrella Infocare are around 230 plus employees as of today. We were established in 2013, founded by two people, and now we have grown up to 230 employees, as I told. And we are the premier consulting partner for AWS, which is the highest level of partnership within AWS. So we have a lot of competencies to speak on our expertise. For example, DevOps, Microsoft Workload, migration, MSP. We are also MSP Partner Competency Certified, WAR, Well Architected Review Certified, and then finally, the topic of this conversation, the data analytics. So we are also a data analytics certified competency partner. We also have other domains in which we work on, namely Citrix. So if you see towards the right, this is something that we are very proud of. We are among the 340 out of 345 partners which are headquartered in India. We are among the 7 who have the data analytics competency certified. In addition to this, we also have so the way how AWS gauges a partner's competency is they also have expert certificates in areas of certain components. For example, EMR and let's say Redshift. So we are also experts on EMR, Redshift, and a lot of other AWS services such as OpenSearch. Having said that, that's kind of a quick company introduction. I'll move on. So within Umbrella, we are working across various domains. So I'll start from right to left. So cloud migration is one of the key, I would say, domain that we work on, and that is kind of a bread and butter as well. So all the lift and shift migrations from on-premise to cloud, be it servers, application, and be it containerization, be it any kind of services, all those we are doing as a part of cloud migration. Similarly, we also provide managed services, 24/7 monitoring of all the deployments across for all the customers. We have also forayed into cloud security services, the third one that you see here from the right. Now, we believe that cloud security will be one of the most hot topic within the market or within the industry for the next 2 or 3 years, because a lot of, I would say, customers have now migrated to cloud, irrespective of be it is AWS, GCP, or Azure, and cloud security will be the next big thing. Similarly, we also are into DevOps, as I mentioned before, containerization, ECS, EKS, Dockers, Kubernetes running on the AWS ecosystem. So we are experts on that as well. Similarly, we are also into big data analytics, the topic of this discussion. I'll talk about a bit in the upcoming slides on what we do in big data analytics exactly, so that I'll not take up the time on this slide. And then finally, the cloud native application development. So we also have a very good application team who are actually developing apps for both web front ends, native applications, as well as modernizations of the existing application, which a lot of our customers are running on premise. Having said that, I'll move ahead. So I'd like to introduce a bit about big data analytics with Umbrella. But before we go ahead and talk about analytics, a lot of I would say, our esteemed customers who have joined on this call, you might be using cloud, or you might be wanting to start on a cloud journey. But the very first question for people who are actually starting out on cloud is, do I really need analytics? And for people who have already started on the cloud, and they are not doing any analytics as of today, do they really need to have an analytics solution? So I've come up with a list of some questions. I'll not walk you through entire things, but I'll talk about a few. Now, for example, you have some sort of data set within your existing ecosystem. And then maybe you would say that I am not a big customer. Should I go for a cloud or not? or let's say if there are some segment of customers that we are big enough customers, and then we already have a deployment on the cloud. What can I do better? So there are these two segments. So I'll talk about the first segment first. So if you are not big enough, you still need cloud. If you have an answer, if you're answering yes in for any of these following questions. So what I mean to say is, if you are not harnessing the power of cloud, you should do it for analytics, because we believe that, and we have seen that data, when you use data and use data to power your business insights, that has surely given a lot of, I would say, positive outcome in terms of growth of the business for customers. Now, you have data, but then in order to use it, you might have skill set gaps, or you might be, let's say, you have challenges around infra, or you have challenges around costing, for example. Then all that you can get rid with cloud. Now, I mean, cloud can be of any flavor, AWS, Azure, or GCP. The idea is to put the idea of cloud across. So if you are doing a data correlation already, so for example, the very first question, so let's say you have multiple touch points of data across customers, right? Maybe somebody is accessing a website, a particular end customer is accessing a website, and you want to track the number of visits to the website or what the person has been doing on the website. And then you want to correlate that with your transactional data of the purchases the customer might have made through the website, right? Now, if you are not correlating the data, you should be doing that. And if you're already doing it, what you need to look into is, are you doing it in a cost-effective and a scalable and a fault-tolerant manner? Now, so these are some of the questions that you see here. Similarly, a lot of customers might say that they want to go into some kind of an AI/ML-based data insight generation. But then they have, let's say, skill set gaps, or for example, they are limited by the technology they are using today, maybe on-premise, right? Or even on cloud, let's say. But then all the cloud vendors, AWS included, they have a plethora of, let's say, out-of-box managed services for, let's say, AI and ML. So one of the key services that we foresee is, for example, AWS Forecast. You just feed in the data, it will forecast the outcome of an inventory requirement, of a retail planning for you without any piece of code being written. So AWS Forecast is a very good technology in the sense that you just feed the data to it and it will generate some outcome for you depending upon the use case or the industry you have. Obviously, we'll not talk about that more in detail, but the idea is to pitch the out-of-box managed services so that you can overcome your skill set gaps or technology limitations. Similarly, the final thing that I want to touch upon, and we'll move ahead, is the cost component. Now, costing, so people who are already on cloud, and obviously I have been on the cloud journey for the last 3 or 4 years, or let's say more than 4 years now. And what we have seen is that cloud can be a costly proposition in certain cases. But then if you use cloud to its most efficient way of using it, then there are a lot of cost savings and optimizations that can be done. A lot of our customers, for example, use a certain set of technology to do an ETL and stuff, but then they might be incurring huge costs. But then if you use and tune your services on cloud to extent, you will end up saving a lot of it, and then it will be highly scalable and fault tolerant. Having said that, I'll move ahead. Now, with this in place, and let's assume that you have now made up your mind, or maybe after this call, you will make up your mind to move into cloud, or if you're already on cloud and want to move to the next level, how can we help? Now, the way how Umbrella Big Data Analytics team gets, or let's say comes into the picture is, let's assume that there is a customer who has a problem within the finance industry that they want to drive up their revenues. Now, if you just see that statement, it is kind of very vague. The revenue, you can drive up revenue through various ways. One of ways is obviously using the data, right? And that is one of the key important ways as well. Now, the way how we come in as experts we are more of tech experts for you. Also, we will bring in some amount of domain expertise. So in this case, for example, let's say a typical project wherein you need to generate insights from data begins with a discovery phase wherein we go into the system and when I say system, we sit with your business experts, understand the problem, see what kind of solutions can be pitched. And then once we have understood the problem, the very first step is to actually consolidate the data. So we use the various, I would say, accelerators to create the data lake, which I think the speaker before me, Megha, has told you about. We create the data lake, consolidate all the data in one place. And then in order to solve the problem, we try to generate insight out of that data using various transformation technologies. These transformation technologies could be very plain, simple old SQLs, or some kind of, let's say, OCR system, maybe if it's a very complicated transformation of some data that you want to do, or it can be, let's say, some kind of business rules that you need to apply on the data to get some output out of it. Now, once you have received the output, it is time to visualize and showcase on a dashboard as to how the data is behaving for you for the, let's say, for the previous trend. And then eventually using those previous trends and visualized patterns, you come up with campaigns on particular segment group of customers, and then target those customers using the various services which are there within the cloud ecosystem. So in this case, AWS has plethora of tools, and they provide the end-to-end, I would say, solution to actually deploy such a use case. So for example, a lot of you might be fine with, let's say, if you are already on AWS or not on AWS and you've read about it. So for data ingestion, transformation, visualization, ETL standard piece, Vega talked well about Glue, EMR, and all the related technologies. But then what about campaigns, right? Because you want to send campaigns out to the customer and actually segment the customers and target them through email and SMS. Now, a lot of you might already know that there is a service called as AWS Pinpoint, which is specifically built for this purpose. So AWS has the complete stack, and we as Umbrella exclusively work on AWS to use this complete stack to give you an end-to-end solution. We will move ahead. Now, so I will not drive the, I'll not be again talking about the data lake, the benefits of the data lake and all. I think we will go into the case studies and you can see some tangible outcomes that have happened for the customers while we have deployed the solution for them. So this is a particular customer wherein they are running loyalty programs. So they are into this loyalty cards business, wherein whenever you purchase something from a store like Big Bazaar, or some kind of, I would say, a GeoMart and all these things, they give out loyalty points depending upon the purchase that you have made. So we actually ended up, I'll go with the problem statement first. So why did the customer approach AWS and Umbrella? Because they had a problem wherein they were running all their workload on a traditional reporting application on-premise, which actually cost them an astronomical figure, so as to speak, to actually implement the reporting solution. And they were running, I mean, the customer was a typical customer wherein they had a mindset of on-premise. I believe a lot of you might have that. But then don't be afraid to try out cloud, because that's the next big thing. So these guys approached us. And then obviously they mentioned that they have huge licensing cost of running the platform, of running around 100 reports within their existing ecosystem, right? And then obviously, since they were running on-premise, they were limited by the technology and the scalability and all kind of performance challenges that they had. So they obviously, when you go for an on-premise, there could be scalability challenges, or let's say fault tolerant, when the systems might not be fault tolerant enough. Similarly, there will be a lot of overhead on the management side of the infrastructure, right? So they approached us with this problem, and they wanted to start on their cloud journey as well. So what we did was we implemented a cloud-based data lake and data reporting solution. I'll not spend a lot of time on this slide because it might get a bit technical. I'll stick to the business now. So in their case, they had an Oracle data warehouse. So we used to collect that data from the on-premise system, put it on the AWS cloud on a day-1 basis, and then used to use open source technologies like Spark. A lot of you might have already heard about it. So we use Spark running on top of AWS Glue. AWS Glue is something like an ETL tool which AWS provides, which Megha also spoke about before. So we use that tool to convert the accumulated data on a day-1 basis and transform into meaningful 100 reports. Now, these reports were obviously used by the end, I would say the customers to actually determine, by the customer to determine the end subscribers, accrued points, month till date, year till date, quarter till date, and stuff like that. But the idea is, if I go into the next slide, this is where I want to spend some time. So by implementing such a solution, the tangible output that they had was there was around 40%, nearly half the savings on license. So if they were going, if they're spending $100 worth of, I would say, license cost before, they were only going to spend $60 with this system in place. The beauty of the system is that there was no licensing cost involved altogether. The complete system was deployed on top of the open source technology such as Apache Spark. All the code was visible to the customer. They could have changed, troubleshooted, any kind of things they could have implemented themselves as well post this implementation. And so this is how it worked. And because the previous generation traditional reporting system was a black box to them, they did not know what was going on there. But in this case, since it was purely open source, it was a win-win. So both in terms of cost as well as in terms of when they implemented the system, they could have implemented changes post the project themselves. Similarly, the performance was one another area that they saw a massive improvement on. They had quite an amount of data. So in their case, they had around 8 terabytes of data. So you don't have to worry about the data sizes as well. The smaller customers might have lesser data sizes, but that does not mean that that is not meant for cloud. It is meant for cloud because of the performance as well as pay-as-you-go model. Now, when you come to the performance of this particular project, the report that used to run 4 hours or that used to take 4 hours in the traditional ecosystem or traditional 40 minutes. Similarly, there were certain reports which they were running due to these licensing and performance limitations once a week. Now they are now due to the cost savings plus due to the better performance, they are now running the same report 3 to 4 times a week. That means better, I would say, decision making because they have the data available 3 or 4 times more. Previously, the decision making might have been weekly. Now, in this case, they could have gone for daily as well. Similarly, the ease of use. Now, a lot of you customers might think that when you go to the cloud, there is a lot of skill sets and everything that is required to actually set up an ETL process, manage it day in and day out. To some extent, it is required. However, it will not be the same as you do it on the on-premise or the older generation of technologies. So as umbrella, what we have come up with our own framework on top of the AWS ecosystem tools such as Glue and EMR. These are the predominant ETL tools within the AWS ecosystem. We have come up with a framework which runs on top of it, which actually is driven through configuration and gives you a low code, no code approach. You don't have to write a single piece of code. You only have to configure a particular table, and then it will, and that particular configuration table will store source and destination table, I would say metadata, and then automatically pull the data from source and inject into the destination. So how this has helped our customers is that obviously it has helped us to, let's say a project which used to take maybe 2 months only for ingestion has been cut down to maybe 2 to 3 weeks. To ingest data from source into destination, because obviously the base of analytics is data, and you have to get data from somewhere into and put it into cloud. So this kind of framework has helped us a lot as umbrella to cut down project times, and hence the commercials also come down. Similarly, once umbrella delivers the project, this framework is free to use for the end customers. They can just configure new sources, new tables, and then the system will just pick up that configuration in the next run and get the data from source to destination without a single piece of code being written. So that is one of the other benefits that the customers have received. So in this particular case, yes, in fact, in all the deployments that we have done. We have handed over the framework, and the customers are happy that they are now able to use a metadata-driven approach to integrate new sources and new tables. Moving on, the second case study that I have is we doing a I would say implementation for one of the leading insurance customer. Now, in this case, very quickly I'll go through. I mean, I've received a time check, so I like to say. In this case, what happened was the customer was a motor insurance customer, and then they had this web front end wherein the end customers, on the end subscribers, used to basically enter their details and then apply for an insurance, right? Now, what they found out was the web front end was perfect, but then when the end subscribers came up into the web front end, there were increased rejection rates due to their incorrect ID being uploaded. Maybe they would have asked the driver's license, and then the customer ended up uploading an Aadhaar card. Also, they were also seeing a high dropout rate. For example, I, as an end customer, even today, I don't like filling up lengthy forms of 20 to 30 boxes to include all my personal details. So this was the same problem encountered by this particular I would say client, wherein their front end was too lengthy for the end customers to fill up, and hence the end customer used to just browse and leave the page. Similarly, they, as a part of this insurance process, they were the end customers were supposed to upload some kind of images to, or let's say some kind of identification proofs to basically give out their details, right? So for that, their application can be processed. So, but then the end customers might use to basically upload low quality images, and hence that resulted in application rejection. Now, so they came to us, both AWS and Umbrella, and then how did we solve the problem? So both customer as well as the Umbrella and AWS as a team, we sat together and understood that there needed to be a process change. So what we finally came up with is that the customer or the end would only upload his identification proof. It can be a PDF or can be an image to the native mobile application or the web front end. We will have an automated OCR process which will automatically capture all the details into the form that we presented to the end customer, be it on the web page or be it on the native application. So how did we implement it? And then this could, so I'll come to the benefits in a moment. So how the way of implementing it is, we used technology like recognition, in which you can actually feed the PDF or a scanned image. It will capture the text out of it and autofill it in the front end. So I'll not go through the entire flow, but the idea was that the front end would invoke the recognition API, will convert the recognition API, and the recognition service, which is a totally managed service, will convert the PDF into text or image into text for the caller, in this case, the front end, and then apply some rules, checks and balances about the quality of the image. Similarly, how much X data can be extracted. Similarly, recognition also gives you with what confidence it has extracted the data. So applying all these rules, and if the confidence of extraction was high, we would just autofill the form, or if the confidence was low, we would have fallen back to the normal way of, I would say, user entering all these details. But in 90% of the cases, we found that the confidence was as high as 90 to 95%, wherein the image was properly converted to text, and all the details of the end subscriber or the end customer who has uploaded the identification was properly captured. So with that being integrated, what were the benefits? So again, tangible benefits. So the customer saw that there were the previous generation way of doing it, all the entries manually, there were 20% increase in the end user signups, because everything is autofilled, and then I just had to take an image of my Aadhaar card, and then all the form was autofilled, and then the customer just has to review it and click on submit. Similarly, the approval process also was faster. Previously, the approval process of someone actually checking the document took 1 day to approve a particular application. Was reduced to 2 hours. Obviously, the approval was instantaneous in this case as well, but then there used to be a manual step to just verify. But then in this case, from 1 day, we cut down to 2 hours. And then also as a side project to this, the customer also captured and all the OCR data into some kind of a searchable repository so that someone can just go in and type a customer's Aadhaar number and they will get all the details about the customer through a searchable document repository. So that was also one of the use cases that we delivered. So, but the main thing is that with autofill in place, they were able to increase the sign up and they were able to, I would say, automate the entire process for the end customers. So I'll quickly move on. I think we are coming to the end. So these are some of the success stories here. You will see some of the largest manufacturing names, so similarly from the finance industry, airline industry, gaming industry, healthcare, loans, telecom. So all these, I would say, are our customers over the course of last 3-4 years. So that is it from my side. We were running on a tight time. Maybe just an hour is not enough to explain everything, obviously. But I'll hand it over back to Aparna, so you can take it from here.
Yeah, please. We are open to Q&A now. Satish will help answer any questions you might have. You can put it on the QA area, or you can put it on chat as well. You can unmute yourself now if you want to ask a question directly. Doesn't look like anyone has any questions. So shall we wrap up, Satish?
Yes, absolutely. So I'd just like to part by saying that the idea is to put the cloud first mentality with the years to come. And if you are already using it, or if you are not using it, you should, for people who are already using it, you guys should be using it much more efficiently. And then for people who are not, it's time that you start your journey with cloud. Yeah, I think I would like to part with that comment.
Yeah, thanks everyone for joining us this evening. And since we had some problem with the polling, we will be sharing a short survey with you. It's not too long. So please help us fill the survey and understand a little more about your data needs. Thanks everyone for coming. Thank you so much. Have a good weekend.
Thanks everyone.